Among all rectangles with a given area, the longer the length of one side, the shorter the length of an adjacent side. If a product is constant, where the constant is positive, a decrease in the value of one factor must accompany an increase in the value of the other factor. As an equation, direct variation has the form y equals k times x, where k does not equal 0. Inverse variation can have the form x times y equals k, y equals k over x, or x equals k over y, where k does not equal 0. When two quantities vary inversely, as one quantity increases, the other decreases proportionally. For both inverse and direct variation, k is the constant of variation. The graph and the table below both show the time needed to bike 24 miles, pedaling at different rates r. First, note the graph on the left. First, considering our axes, our horizontal axis is rate in miles per hour, and our vertical axis is time in hours. We have a graph and several points labeled. 3, 8, so 3 miles per hour, associated with a time of 8 hours, 6, 4, 12, 2, and 24, 1. Note the inverse variation, t equals 24 divided by r, models this situation. Now consider the table. The left column, rate in miles per hour, and time in hours. A rate of 3 miles per hour is associated with a time of 8 hours, a rate of 6 miles per hour associated with a time of 4 hours, a rate 12, time 2, rate 24, time 1. You can also see the inverse relationship t equals 24 over r in this table. Notice that the product of the rate and time is always 24. The constant of variation is 24. Problem 1. Identifying direct and inverse variations. Is the relationship between the variables a direct variation, an inverse variation, or neither? Write function models for the direct and inverse variations. Part A. A table. The left column, x's, the right column, y's associated with those x's. An x of 2 is associated with a y of 15, x of 4 associated with a y of 7.5, 10 and 3, and 15 and 2. Note, as x increases, y decreases. This might be an inverse relationship. A plot, shown here at the right, confirms that an inverse relationship is possible. Test to see whether x times y, the product, is constant. Well, 2 times 15 is 30. 4 times 7.5 is also 30. 10 times 3, 30. And 15 times 2, 30. The product of each pair is 30, so x times y equals 30, and y varies inversely with x. The constant of variation is that product, 30, and the function model is y equals 30 divided by x. Note we could also write x equals 30 divided by y, or xy equals 30. Part B. How about this table? An x of 2 related to a y of 10, x of 4, y of 8, 10, 3, and 15, 1.5. A plot of the points suggests that an inverse relationship is possible. Test to see whether the products of x and y are constant. First, 2 times 10 is 20. Next, 4 times 8 is 32. So our products are not constant. We can check the rest. 10 times 3 is 30. 15 times 1.5, 22.5. So we state, since the products are not constant, the relationship is not an inverse variation. Your turn. Is the relationship between the variables a direct variation, an inverse variation, or neither? Write function models for the direct and inverse variations.